Hello everybody, welcome to Module 6 of the Functionality program. So in the first couple of videos of this module, we're going to actually review concepts we learned in the book and the program thus far, and then we will spend the last few videos actually creating our own project from scratch, similar to the previous program. So in this video, we're going to review functions, and we're going to talk about indexing and assignment, both of which were introduced in the book. So go ahead and go to REPL, and then go ahead and click Login up here. And you can log into your account, obviously. Once you've logged in, then you can go and click create a new REPL up here, and obviously we're still using Python. You can name it something like functionality test or anything that will indicate that this is just us sort of learning about the concepts and playing around with some of the material in the functionality booklet and program. Once you have a name you like, go ahead and create the REPL. And you should see this familiar layout. So you have your file structure on the left, your code editor in the middle, and your terminal or your console on the right. So the first thing we'll talk about are functions. And as we talked about in booklet 4, there's two types of functions. There's user-defined functions and built-in functions. So vanilla Python has around 60 to 70 built-in functions that each do various things. Many of them are not commonly used, but there are some that are worth knowing and that may be helpful in the long run. So as we talked about with any function, the way to call it is its name. So let's say we want to call the power function. We type its name, which is pow, and then you open and close a parenthesis. Now, REPL does this cool thing where it kind of shows you what kind of numbers or arguments that this built-in function takes. So we have our base, we have our exponent, and then we have a mod number if we want, but that's an optional argument, so we don't need to worry about it. So if we wanted to calculate something like 7 raised to the power 5, we would type in 7 as our base, and then arguments are separated by commas, and 5. And you can actually see REPL's telling us right here, it's equivalent to base, and then this is the exponential operator and our exponent with two arguments, and if we put the third argument with the modulo, it will calculate the modulo of our result. Now, if we want to actually display the result, we can wrap this in a print statement. Print is also a function, and it just takes an argument and displays it in the terminal. So if you just go ahead and run this up here, we'll see 16807, and you can obviously check this number in your calculator. Now, the reason that power is one of the functions I'm choosing to display is because Python's math functions are actually very useful. There's no limit to how big integers can be in Python, and so a lot of times data scientists, people who need to do large calculations, which a calculator cannot do, they often turn to Python because it can display very large results. And so we can kind of see that in action. If we take a huge number, maybe we do like 567, and we raise it to the power of 20. Now, if you did this on a calculator, it probably would not be able to display all the digits. But if we run it here, we see we get all of the digits accurately. And this is the exact answer or result of 567 raised to the power 20. So that is one of the cool things about Python, and it's one of the reasons why data scientists often use Python for their tasks. Now, power is obviously one function. There's more functions like absolute value, which we just talked about. You can put in a number like we say -10, and if we click run, we should get 10 because the absolute value of a negative number is just its positive counterpart. There are also some other functions which you may not necessarily consider a traditional function, but they still operate in the same way. So we talked about type conversions. So let's say that we have a string, but the string has a number inside of it, something like this. So hello is equal to 1. Now, in this case, 1 is considered a string, not an integer, because it's wrapped in quotes. But we can use something called the int conversion. So if we do a variable called numeric, we do int hello, this is going to try to convert whatever argument it gets into an integer. Now, if it can't convert it, it will give us an error. But since we have an easy 1, it will be able to convert it. And the way we can check this is if we were to print numeric plus 5. Now, if numeric was still a string, it would not be able to add 5 to it. The computer would not know how to add a string in an integer. But if numeric is in fact an integer, it's 1, we should see 6 on the screen. So when we run this, we see we have 6. And so this is sort of a function because it's converting types. And so you could do this with, there's a string converter, a dictionary converter, a list converter, etc., etc. Now, if I were to make this something else, maybe like GH4, just sort of random characters in my string, and then I ran this, you would see that I get a value error, invalid literal for int with base 10, gh4. So it does not know what gh4 is. It's clearly not a number, and so it gives me an error. So this only works if it's able to actually parse what we pass in as an argument to the data type we've requested. Now, we can also talk about user-defined functions. So they work in much of the same way, but instead of being built into Python, we have to create them ourselves. And so when you're writing programs that may be more complicated, where you have to do a certain number of steps or a certain pattern repeatedly, instead of writing out all the steps each time, you can name those set of steps as a function, and then you can just call the function. So one of the examples we talked about in the booklet was adding two numbers. So let's do something like multiplying two numbers. We can do def, which is our keyword for creating a function. Then we give it a name. Now, names should not include dashes. They can include underscores, letters, and numbers, but they cannot start with a number, and they cannot have any dashes. So those are really the naming conventions for variables, for functions, anything of that nature. That's just how Python likes to do it. Now, to define it, we put our parentheses, and then we put a colon, and then the rest of our code for the function will be indented one block over underneath this. Now, if we're multiplying numbers though, we're going to need to get the numbers, and so a function receives input in the form of arguments. So we can name our arguments like this, num1, num2, and num1 and num2 are what we call local variables. They're only defined within the multiply numbers function. So we can't print num1 and num2 later because the computer will not know what they are. But within the function, we can use them to tell it what we want to do with the arguments passed in. So all we want to do is get our result as a variable, and that should equal num1 times num2. Then we can just return this result with the return keyword. So what this function is doing, it takes two numbers, it multiplies them together, saves it to a variable, and returns the value of that variable. So if we were to call multiply numbers, and let's say we did 5 and 10 as our arguments, so 50, right? And we run this code. You see we get no output. And the reason is we're returning a result, but we're not displaying any result. So what we could do is we could set the return value equal to a variable. So we could say our answer is equal to multiply numbers 5, 10. Now if we print answer, click run, you'll see we get 50. So we can get the value back using a function. Now the other thing that we could also do is print within our actual function. So within the function, we could print result, then we could get rid of our print answer down here. When we run it, we see it still prints 50. So anytime the function is called, it will print the result that it gets. Now, you can also completely remove return keywords from functions. You don't have to return anything. The only thing here is then we can no longer set it equal to answer. So we just call the function in this manner, and since we have a print in here, when we run this, we'll print one more time. So functions really, they can be pretty dynamic because they can return a value, they can not return a value, they can display values, and they can also not. And in terms of the arguments, functions can take anywhere from 0 to however many arguments you want to pass to them. So this is obviously a very basic function, the multiply function, and we would obviously not need to create something like that because we can just use a single statement, which is a multiply operator. But obviously when you start writing code where you have to do 50 lines over and over, then it's going to definitely be more useful to just define a function with a name and just call it in that manner. The important thing to note is that all functions are called in the same way. Their name, open and close parentheses, and then the arguments are in order within the parentheses. Now moving to indexing and assignment, which was another key concept we talked about in the booklet. Indexing is really just the concept of getting values from a list, a series, based on their location. So let's say we have a list called mylist, and it just has some random numbers in it, like this. Now, if we wanted to get the first number or the last number, there needs to be a way for the computer to understand what specifically we want. And in most coding languages, this is called indexing. So I'll just create a print statement. Now, if we want to get the first number, then we're going to use indexing, and indexing is done with square brackets, and indexing always starts at 0. So if I do print my list 0, you'll see I get 1, which is our first number. Now if I want to get the last number, I could obviously count. I could do 0, 1, 2, 3, 4, or I could just use -1. And so that tells the computer to start at the end and move backwards 1. If I do that, you see 3, which is our last number. So this is obviously a useful tool because at various times you may want to access specific locations in a list, in a series, and indexing makes that possible. Now, indexing can also be extended to slicing, and so slicing is getting a range of numbers from a list based on still their location. So if I wanted to get the first 3 numbers, what I would do is I would put the first index, which is 0, the first number. Now, the first 3 would be 0, 1, 2, right? But we're going to actually put a 3 right here. So this is going to tell the computer start at 0 and go up to 3, but not including 3. So stop before it. So if I go ahead and print this, I'll get 146, the first 3 numbers. And so an easy way to always make sure you're getting the right amount is if you want 3 numbers, then the difference between your 2 arguments in the index should be 3. So 3 minus 0 is 3. And what you'll see is we also get the same type back as my list. We get another list, obviously. So if this were a tuple, we would get a tuple, and so on and so forth. So it's important thing to note is that when you slice, you're going to get the same type back. It's not always going to be the same type as something else in your code may have been. So one of the other things is that if we want to go all the way through the end, like let's say we want to get from the second number through the end, we're going to start with index 1, but what we're going to do is open this colon and then leave it open. So nothing is going to be in place for our second number. When we run this, we'll see 4623, we got through the end. And so this tells the computer we want everything else in the list after our starting index. We don't want to stop. Now if we want just the middle numbers and we don't want that last number, once again we can use the -1 to tell it to stop at 3. So we'll see 462. And so this is obviously just an extension of indexing. It's very similar, and the only thing you're adding is a colon and where you want to stop at. And so once again, this indexing and slicing are 2 very important features. There's things that you will frequently use as you continue to code. Now the next application, obviously, of indexing is I can obviously extract a value, but how can I change a value? So the main thing to note is that with assignment is what we call it. Let's say that we want to change the first value in my list. So let's say this is like a list of money I've spent on a specific item over the past 5 days. And let's say maybe I found out today that I actually spent $5 on the first day, not 1. Now I could just create a new list, my list 2, and then I could, type in 5 and then keep everything else the same. But that's not super time efficient. It's not memory efficient either. So the way that we actually change this is first we access our first number. And so we do that with the indexing we just talked about. So my list 0. Then we just do a simple equals 5. So we just set the new value of my list 0. And if we print my list after doing that and click run up here, so we get 54623. And so my list has been updated. Now, the main thing to note here is that this only works with mutable types. So in the last booklet, we talked about mutable versus non-mutable. Lists are obviously mutable. They can be changed after being created. But if I try to do this with a string, it's not going to work. So let's do, we can leave this down here. Let's do my string. And let's say I type in something like AFYT, just random letters. Obviously, they don't mean anything. And let's say I want to change the first letter in this case to C. If I try to do something like this, my string 0, because strings can also be indexed. So any type, any series type can be indexed. I'm talking about assignment can only be done with mutable types. But if I try to do this and I just make my string 0 equals C, and then I try to print my string, let's see what the code tells us. So we get this output. So one of the cool things about Python is we have an error down here, but we run everything else up to there. We get string object does not support item assignment. And the reason for that is strings are not mutable. So they cannot be changed after being created. They can be altered, appended, but you cannot change individual characters within them without creating a new string. So assignment is once again really just indexing with an equal sign. It's not much more difficult, it's not very much more complicated, but like we talked about in the enumerate function in this program, it's something that we commonly use because lists that's a whole point of a list, is that it's often updated. You know, maybe you're making a checkbox type of system where you need to know if something has been completed or not. Either way, lists and indexing go hand in hand, and list and assignment go hand in hand. You can obviously use indexing with strings with other types like we talked about, but you cannot change their values in place. In the next video, we'll actually dive more into detail on how loops work, which was the other key topic introduced in booklet 4.